Hi, everybody. Welcome to my channel, Numbers with Nora. This channel is about math tutoring where you can sit there and see step-by-step problems, as well as put in comments on any kind of math problems you would want me to work out. So today, this video is the subject of geometry, chapter 3. We're doing 3.3, prove lines are parallel. And again, I'm going to be using the Larson geometry book. You'll be able to sit there and get access to the book on the bottom of this video, either in the comments or in the video section. You can follow along in that book, or you can use the geometry book that you have as well to follow along, seeing that many of the explanations are very, very similar. So let's get started. So the objective of this chapter is you will use angle relationships to prove that lines are parallel. So first and always, we want to start with our math vocabulary so we understand what we are looking at. The first one is going to be paragraph proofs. This is the method that we use. The method of demonstrating mathematical statements by writing factual statements in a paragraph. Okay, so this is just like a way that we can sit there and do a proof, but we write it in paragraph form. And converse, this is kind of like an old vocab word, but we will be looking at the converse for some of our postulates and proofs in this section. So remember, the converse is just a way of reversing the order of the statements in a logical or conditional statement. And I'll just do an example of that quickly. So say we have a conditional statement, and I'll just put CS right now for conditional statement of if P, then Q. Then that means our converse of the statement. Let me put it like this. Our converse of that statement would just literally be switching around our hypothesis in our statement. So we would put if Q, then P, and we're just literally switching around our two statements, our P and our Q. Okay, and we're going to see an example of that when we look at our postulates and theorems down below. And then we have a two-column proof, and this is the method of demonstrating mathematical statements by writing our reasons in two columns. Okay. And that's mostly how we're going to write most of our proofs in two-column statements, unless it's asking us to write it in a paragraph form. All right. So the first thing we're going to look at is our postulates. Now in video 3 or section 3.2, the video before this, we do have a postulate that's similar to this, but this is going to be the converse of it. Okay. So this one is if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So before in 3.2 section, we were saying that the lines are parallel, then the two angles are congruent. This is the converse of that. We're sitting there assuming first that our angles are congruent, and then we're proving that the two lines are parallel due to those angles being congruent. All right, so that's our first postulate, is the corresponding angles converse. Okay. And let's look at an example of this one right here. So this is example 1, apply the corresponding angles converse. Find the value of x that makes m parallel. That's our symbol for parallel, the two lines, n. All right. So let's look at what they give us first. So since these two lines they gave us are parallel, we want to find when they are parallel according to our corresponding angles converse. So that means that these two angles right here, my corresponding angles, are going to have to be equal to each other. All right. And we have to solve for x, so we're going to set them equal to each other and then solve for x. Right. It's going to be quicker if I type it out. So I'm just going to set those two statements equal to each other. 3x plus 5 equals 65. And right here is where we just sit there and use algebra to solve for x. So I subtract 5 from both sides. I'm going to get 3x equals 60. Oops. And then I divide both sides by 3. And then when I do that, I'm just going to get x is equal to 20. So that means that these two lines are parallel. M parallel. Where's my parallel there? It's parallel n when x equals 20. Right? So that's their example of using that postulates with example 1. And now we're going to sit there and look at the rest of the theorems that we have in this section as well. And the theorems are kind of similar. From 3.2, we had our theorems, and this is just going to be the converse of those theorems that we saw in 3.2, where we're seeing that our angles are congruent. And since our angles are congruent, then we can say our lines are parallel. All right, so theorem 3.4, alternate interior angles converse. If two lines are cut by transversal, so the alternate interior angles are congruent, then the lines are parallel. So right here, they're saying that J and K are parallel because we're stating that we have two alternate interior angles. Right? 3.5, same thing, alternate exterior angles converse. We're saying that since my angle 1 and 8 are congruent, then I can say that J and K are parallel. All right. And again, down here, consecutive interior angle converse. Since I have two consecutive interior angles, then I can conclude that J and K are congruent. And remember, 5 and 3 aren't going to be equal to each other. When I add them together, they're going to be supplementary. That means when I add them together, they're going to equal 180 degrees. Okay. And if that happens, then my J and K are parallel. So those are the postulates and theorems we're going to be using. Let's do a couple examples to get used to this. So let's see example 2. Solve a real world problem. This one says snake patterns. How can you tell whether the sides of the pattern are parallel in the photo of a diamondback snake? So right here, they give us a photo. Right here, you sit there and see that they mark already that these two lines are parallel. All right. So since they already marked that for us, then we kind of already know from one of our theorems, we'll name this line L and this one M, so there's no confusion. We can sit there and say the solution. All right, so let's write out our solution to this one. Oops. Zoom up a little bit. All right, so how can you tell that the two lines are parallel? We know because angles. Because the two angles are congruent by the alternative interior angles converse theorem, lines L and M are parallel to each other. Okay, and that just means parallel. And that stands for theorem right there. All right. So because they are alternate interior angles, then we know by the alternate interior angles converse theorem that line L and M are parallel, right? Cool. So let's go down to example 3 now. This is going to get more proof driven. And again, like I said, we're going to sit there and start with just writing 2-column proofs. If you want to see what this would look like in a paragraph proof, just sit there and put down in the comments, and I can sit there and post back to you and show you what it would look like as a paragraph. All right. So for example 3, prove the alternate interior angles converse. Prove that if 2 lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So we're given that angle 4 is congruent to angle 5, these two right here. We need to prove or show that G, oops, it's gonna let me write. We want to show that G parallel to H, okay? And we're going to do that with our steps and with our theorems that we have. All right, let me insert this so it's easier for us to type it out. Perfect. All right, so let's start with our statement. We always start with our given, so we know angle 4. I'll just put angle 4. Then I can say congruent. I'll write the 4, 5. I'll actually draw in the little line. I don't have the little line to draw in on there, sorry. Let me see if it will let me draw it in. There we go. Angle congruent. This one. Right? Sorry, that's a little sloppy. And that's going to be given. Oops, what happened? I'm going to write it out. It's not liking me type in. I'm going to write given. Right? And I'm going to use abbreviations just so it doesn't take me as long. All right, so that's step 1. Next, I want to sit there and see what else they provide me. They provide me with this angle right here, 1. When I sit there and look really close, I see that angle 4 has a relationship with angle 1. They're both vertical angles. Vertical angles are congruent, so that's going to help us out in a way. Let's write it down. I also given that angle 1 congruent to angle 4. And this is by the vertical angle theorem. Again, I'm just going to write abbreviations because I don't want to take forever typing it out. Vertical angle theorem. Right. Now let's see what else we're provided. Another thing I noticed now, I can kind of relate 1 and 5 together. If I can relate 1 and 5 together, and they're both hitting my transversal like that, they can create corresponding angles, right? So I know that 1 and 5 are congruent by the transitive property, because 4 is equal to 5, but 4 is also equal to angle 1, right? So that means angle 5 congruent to angle 4. Okay. And this is by the transitive property. Again, I'm going to abbreviate property. Right. And then our last step, we can finally prove that G is parallel to H. Because these are 2 corresponding angles. And from our theorems, or this one, our postulates that we looked at above, if I could sit there and prove that 2 corresponding angles are on my transversal in between these two lines, then I could sit there and say the corresponding angles converse postulate makes G and H parallel. So this is by the corresponding angles conversed. Converse. Oop, that's ugly V. Converse. And then postulate. Okay. If you guys could write it all out on your homework, I would write it all out. But just for the time and sake of the video, I don't want to spend time writing it like this. Okay. And that proves that G and H are parallel. And we're going to do another proof because I want you guys to get comfortable with proofs because we're going to start doing more and more proofs throughout geometry, right? So this one, again, we're going to do a 2-column proof. For example, 4, it says write a paragraph proof. And the figure R parallel to S and angle 1 is congruent to angle 3. They give us that. They want us to prove that P and Q are parallel. So they want us to show that these two are parallel. But right now, I only know that it's given that R and S are parallel. Okay. But we want to show that these two are parallel. Okay. So we always start with our statements. Let's see if it will let me type this time. All right, so we always start with our statements. And then our reasons on the other side. Okay. All right, so our first statement, we know that R is parallel. R parallel to S. And it's given that angle 1, I'll just put A and G1, angle 1 and angle 3 are congruent. All right. And you guys can write it in the congruent, like angle 1 and the sign congruent if you want. It's just not letting me write it right here. And that reason is given. Our next thing that we want to look at is what we can use, right? Another thing I noticed, since it's given that R and S are parallel, and we know 1 and 3 are congruent, since R and S are parallel, we can look at Q right here, this line right here, as a transversal that cuts through them, okay? So since I can sit there and look at Q as a transversal that cuts through them, okay, oops, this right here, that cuts through my R and S, then I know that angle 1 and angle 2 have to be congruent by the corresponding angles theorem or postulates, right? So let's include that one. I can say angle 1 and angle 2 congruent. And our reason is because the corresponding angles postulate, and it's not going to be the converse because they already gave us that these lines are parallel. So then I know that these are 1 and 2 have to be congruent. Okay, so it's not the converse, it's just the regular corresponding angles postulate. Right, now let's see what else we can conclude. Now, again, we're going to have to sit there and use that transitive property because then I see that angle 1 is congruent to angle 3. And then also angle 1 congruent to angle 2 as well. Okay, so I'm going to use that transitive property. I can go angle 3 and angle 2 congruent. And this is by the transitive property. Right, that's by the transitive property. And then now we see, we go back to our drawing board and our visualize this. If I sit there and say that angle 3 and 2 are congruent, then now I can kind of look as R as my transversal. And these can be considered, and then P and Q, which we're trying to prove, they're parallel. But if I look at R as a transversal, then I can consider 3 and 2 to be alternate interior angles, okay? So now I'm going to use that converse theorem that we learned before. So let's go back in here. So I can sit there and say P parallel to Q. And our reason, because our alternate interior angles converse theorem. Okay. And that proves that, and then we prove what they asked us to prove. Okay. So it's always best to start out with 2-column proofs and kind of look at the image that they give you and work your way through step by step. Because usually they give you what you need. You just have to figure out which postulates and which theorems you're going to use. And we'll do a lot more proofs and a lot more practice proofs. Okay. So that's the end of this section, 3.3. Put in comments, any homework questions you have, if you want to see anything step by step. Any proofs you want me to write out, just let me know. Put in the comments and I can do that for you and send it to you. And if you would like to subscribe or leave a message in the comments, like I said, you can. Thanks, you guys. And I'll see you next time.